the identities. Now, an identity is a statement, turn around, pay attention, is a statement that is always true. So, for example, this is an equation, but it isn't always true. It's only true if x equals 3. This, on the other hand, would be always true, right? That's called an identity. So today we're going to look at some identities. Now, I would encourage you, any identities that Mr. Passwater has included in the notes, I would encourage you to start memorizing them. Because remember, what kind of reference sheet do you get on the AP pre-calculus exam? None. None. You need to know it all. Now, when you take your AP calculus exam, that's different, but not this one. You gotta know everything, okay? So if he has them in the notes, there are zillions of identities, guys. There are zillions. When I took this class, we memorized them all. But the curriculum now doesn't include everything, but it includes some, and those are the ones you need to know. So, here's what I want you to think about. Just look up here for a minute. Just look up here for a second. I'm going to draw a circle. And I'm going to let the radius of that circle be r. Okay, so it's not the unit circle, it's just some circle with a radius of r. And I'm going to call this point x, comma 1. If I create a triangle in that circle, would you agree that this side of the triangle is x, and this side of the triangle is y? And since that's a right triangle, can I say that x squared plus y squared equals r squared? True statement. Can I divide everything in there by r squared? So x squared over r squared, y squared over r squared equals 1. Now this is a case where division by a variable, I divided by r, is okay. Because don't I know r can't be 0? I know that. There is no 0 r. So therefore, this is legit. All right, one more thing. X over r squared, y over r squared equals what? I just rewrote this as a fraction squared instead of the individual pieces squared. Would you agree that's okay? So far, everything I've done is completely legitimate, right? Now, anybody know anything about x over r? That is cosine. So what this is saying to me is cosine squared of my angle, I'll call it theta, whatever that angle is, cosine squared plus sine squared equals 1. Always. That's an identity. So if you picked an angle and found its cosine and squared it, and found its sine and squared it, and added them together, you would get 1. Let's just pick one. Let's go to our unit circle. What are the sine and cosine of my pi over 6 angle? What's my cosine of pi over 6? 3 over 2 and 1/2. Okay, so that's the cosine, and that's the sine. I'm on my unit circle. So that's the cosine and the sine. So what is root 3 over 2 squared? 3/4. What is 1/2 squared? Oh my golly, what happens when I add them together?
1.
Always, always. Sine squared plus cosine squared is 1. Always.
How? How does that work?
I just proved it.
Yeah, you did.
That was like the
It's
perfect
so weird.
explanation.
So sine squared plus cosine
It's just
squared is
bad for
always
them.
going to be 1. Now,
How?
It's cat. It's
gotta be
literally
cat.
just the Pythagorean theorem.
exactly. In fact,
Nuh-uh.
this
Stop
is
touching the chair.
this is called a Pythagorean identity. There are two more,
No.
all right? So I'm gonna take this guy, right here, and I am gonna divide by cosine squared. Now, if I do that, I have to make a note over to the side. Cosine cannot be 0. This isn't gonna work if cosine is 0. But you'll see what's gonna happen here in a second.
Why'd you put it here?
What is sine squared over cosine squared? Tangent squared plus 1. What's 1 over cosine squared? Secant squared. So, this only exists when cosine isn't 0, but that makes perfectly good sense because since tangent sine over cosine, it isn't going to exist anyway. So, this is another one of your Pythagorean identities. 1 plus tangent squared is secant squared. And of course, we understand that these can be undefined, and therefore it won't work. This identity won't work if you're at pi over 2, for example, because there's no tangent, or secant at pi over 2. What if I would have divided everything by sine squared? What would that one look like if I divided by sine squared? 1 plus cosine over sine is, well, what's sine over cosine? So sine over cosine is tangent, so cosine over sine is cotangent squared. And then what's 1 over sine? Cosecant squared, yeah. So these are your 3 Pythagorean identities. They are in Mr. Passwater's notes. They are things you need to know. So sine squared plus cosine squared is 1. 1 plus tangent squared is secant squared. And 1 plus cotangent squared is cosecant squared. Now, you're thinking right now, okay, yeah, we're gonna do stuff with this, so just hang on. We're gonna do things with this. Those are called the Pythagorean identities. Now, I'm gonna hold off on the inverses for a second and go to example 1 and see if you can make this work. So example 1 says we have tangent divided by cosecant, and we want to rewrite this so that the only function we have is cosine. So right now I have a tangent and a cosecant, and I only want cosines. All right, tell me what you know about tangent. What do you know about tangent? What does tangent equal? Okay, in terms of the trig functions, what does it equal? Sine over cosine. So I'm going to rewrite that as sine over cosine. What do we know about cosecant? 1 over sine. So now I have this fraction divided by this fraction. I can maybe invert and multiply. And this ends up equaling sine squared over cosine. Would you agree with that? Now, the direction said only cosines. So I kind of erased it here, but let's step over here for a second. And remember that sine squared plus cosine squared equals what? So what is sine squared? What does sine squared alone equal? If sine squared plus cosine squared is 1, what does sine squared equal? 1 minus cosine squared. So I can come over here and change that to 1 minus cosine squared. And oh my goodness. All cosines. All done. We did it. We took that guy right there, changed it into what I call its basic fractions, sine over cosine, 1 over sine, did some arithmetic, and then used our Pythagorean identity to rewrite the sine squared in terms of cosine squared. Now, that trick only works if they're squared. So you can change sine squared into 1 minus cosine squared, but this is not 1 minus sine. You can't do it with the straight functions. They have to be squared to rewrite them. Okay. What, Owen? How did I get from where?
How'd you get from sine squared x over cosine to, to there?
To here. I know that since sine squared plus cosine squared is 1, sine squared is 1 minus cosine squared.
Yeah, alright.
So then I substituted out the sine squared and replaced it
Okay, I
with.
thought you jumped from there to there, and I was like,
Yeah, well, I went from here to here, but that's why I was able to do that.
yeah.
So you're saying if it's just sine x on top, you can't do that because it's not with the identity?
It's not squared. It's not squared.
Could you square root it?
You could, but it would be square rooting the whole difference, yeah. All right, okay, now, look, that was example 1. Right under example 1, there are some more identities. These are called the sum and difference and the double angle identities. All right, so let's look at these real quick and make sure you understand what's going on. This is a lot, you guys. There's a lot in this section, and that's why I'm encouraging you to start to learn them. Start to learn them right now. So, the first one says the sine of alpha plus beta and the sine of alpha minus beta. Now, he wrote those together using the plus or minus. That's perfectly okay. I'm going to separate them. You don't need to. You can keep them together, but I want you to understand how the signs work, these guys. If it's an addition, if you're finding the sine of two angles added together, it's sine of the first, cosine of the second, plus cosine of the first, sine of the second. If it's a subtraction, the formula is exactly the same, but it's a subtraction. So these are your sum and difference identities, sum and difference for the sign. We're going to use this in a minute. Now, what about the cosine? Well, those are, I can split those two, I don't need to, but what you have to really pay attention to is, okay, cosine sum. Cosine of the first, cosine of the second, minus sine of the first, sine of the second. So do you notice on his work how in the formula the sign is flipped upside down? It's minus plus. That's because when there's a plus here, there's a minus here in the cosine. So this one would be cosine cosine plus sine.
Wait, why did it switch for the cosine?
Okay, that's the formula. I don't have time to derive it, but it is switched. I mean, these are identities.
Okay.
So what does that mean? They're always true. We don't get to argue them, we don't get to change them, they are fact, all right? I derived the first one, I really don't have time to derive all these, but Google it, it's derivable. And it isn't really that hard.
How did they
The
discover?
issue is it uses the law of cosines, I think, and they don't
How did they discover this?
It's all derivable, guys just sat around playing with it.
Is there any like way you could ever use that in real life?
Yes, we're gonna do it. First, we gotta get the formulas.
Do you not remember the clock?
Trial and error.
Okay, so these are the sum and difference identities, the ones you need to know. Okay, there are 10, that's all 6 functions have them. You need to know sine and cosine. You also need to know what are called the double angle identities. And those come directly from these. So the double angle identities, for sine, it's 2 sine cosine. So if you are taking the sine of twice an angle, that's how you do it. The cosine one is a little bit trickier. First of all, that's a minus in there, so make sure you're paying attention to that. And since I just erased it, but we just talked about, what did we say sine squared was equal to?
One minus
So here's one version right here. But if I took that sine squared and replaced it with 1 minus cosine squared, that would be 2 cosine squared minus 1. That is another version of the double angle cosine. And then, if I took cosine squared and replaced it with 1 minus sine squared, I would get another one. So there are actually 3 versions of the double angle cosine. He's got them all listed there for you. Back in the old days, when all the kids had to memorize everything, I always said, memorize this one. Because if you memorize that one, can you figure these 2 out pretty easily? Yeah. But it's up to you. If you're a good memorizer, I know all of them. Then you need to know one. You need to know the double angle cosine. Oh my Lord, this is for you. Rolling through this stuff. Yeah, because it's all here. You're just gonna memorize it. Now, how are we gonna use it? Let's look at example 2. So look at example 2.
It explains.
All right, so example 2, here we go. 2 sine cosine. Look at the list of formulas. Let's see, they're all in boxes. Forget the pi over 14s for a second. What formula has the form 2 times sine times cosine? Forget these specific angles.
Double angles.
So sine twice the angle. But in our problem, the angle is pi over 14. Right? The formula said 2 sine cosine is the sine of 2 theta. So your theta is pi over 14. So this is the sine of pi over 7. And that's the answer to the question. So one of those should say sine pi over 7. C. Look at the next one. We have 4 cosine 2x. What do we know about cosine 2x? Well, I'm gonna look at all my answer choices. No, they're kind of all mixed up. So, this is what I know about cosine 2x. So I'll just try that one first. I'll just try that one. So 4 times cosine squared minus sine squared. Is that an option on my paper? Is that one of my multiple choice options?
Yeah.
Is it? I didn't think it was.
No.
No, It's not. So, it's okay. I really didn't know which one to use. I'm gonna use the other one now, or one of the other ones. So 4 times 2 cosine squared minus 1. That is another one of my options. Is that on the paper?
Nah.
Wait, isn't it C?
Yeah, it's C.
Isn't it C?
Oh, yeah, you just review.
Yeah. Isn't it C, everyone?
Yeah.
So that is your answer there. Alright, let's look at the next problem. Try to stay open-minded and not be overwhelmed. Stay open-minded. Alright, cosine pi over 8, cosine pi over 16, minus sine pi over 8, sine pi over 16. Okay. Look at, I'm on example 4. We're going in order. Right
I
here.
don't know, I'm just flipping, looking back and forth.
Okay. So, which formula has this pattern? Don't look at the specific angles. Cosine, cosine, minus sine, sine. What is that? No, that's not cosine
Sum
double
and difference,
angle.
identity, cosine.
That's cosine, angle plus angle.
Yeah.
This is like your alpha and beta. And that's a minus. So the formula is a plus. Now, what are my alpha and beta? Pi over 8 and pi over 16. I'm adding them together. So common denominator, 3 pi over 16. Is that an option? Cosine 3 pi over 16.
Yeah. C.
Okay, Enzo, this is your formula. Okay, it is the formula for the cosine of alpha plus beta. Okay, that is the formula. So you've got to look at your formulas. This is the formula, right here. That is the formula for cosine alpha plus beta. That's alpha and that's beta. Okay? You practice our formulas. I know this is day 1, it's a little overwhelming, but try to stay focused. All right. Example 5. Guys, you just gotta stay focused, all right? Quit whining and complaining, just keep open-minded and let's go. Example 5, we got a point on our circle that's 512. They tell us the hypotenuse is, or the radius is 13, but we could have figured that out on our own, but they told us that. Which of the, what, I think it means, what is the value of sine 2 theta? Well, first of all, what's the formula for the sine of 2 theta?
2 sine theta cosine
2 sine theta cosine theta. So I need to multiply 2 times the sine times the cosine, and that will be the answer to the question. So a couple different ways you can think about this. Can you tell me what the cosine of that angle is? Hmm?
I'm thinking of like the.
You're thinking of a certain unit circle, and it's not. Cosine is x over r. So it's 5 over 13. It's also adjacent over hypotenuse, 5 over 13. So the cosine is 5 over 13. What's the sine of that angle right there? 12 over 13. So what is the answer to the question? 120 over 169, if I just multiply all those numbers together correctly, hopefully. That's not so bad. It's actually kind of easy. Let's look at this.
Where's the sign?
People always just want to distribute, you have to use your formulas. Only way to do the problem is use your formulas. And they get easier with practice, so you might want to go back and redo some of those problems. Let's look at these. Okay. 2 truths and a lie. That means that 2 of the statements are true and 1 of them is false. So we have to figure out which of these statements is true and which is false. All right? So let's do number 1 together.
Quick interruption. Can you please send Landon Hughes to student services?
Yep.
Thank you.
Quickly, you don't want to miss any of this.
This is a horrible time.
So here we go. I'm gonna look at statement 1. I'm trying to figure out if it's true or not. So take a look at the statement. Again, don't look at the specific angles. Look at the pattern. What is that a formula for? It is sine cosine plus cosine sine. What is that? That's a formula for something. Which formula is that? It's a sine formula. And it's the sine of alpha plus beta. That's right, alpha plus beta. Only we don't have alpha and beta, we have pi over 3 and 2 pi over 3. So that is a formula for the sine of pi. Whoop, that's true, right? That's what we're trying to do, sine pi. So statement 1 is true. Right, what about statement 2? Isn't statement 2 the same formula?
Yeah,
But now the angles are 3 pi over 4 and pi over 4, which adds up to pi. So that's true. Well, what about statement 3? Isn't that the same formula? But they don't add up to pi, they add up to 6/4, 3/2. So there's your false statement. Does that make sense to everyone? You see how we're doing that? All right, spend a few minutes on the rest of the problems on this page, and let's see if we can come up with 2 truths, 2 truths and 1 false. And once we figure out why, or which ones are false, we're gonna go back and try to make them true. But let's figure out which ones are false first.
This is 4.
Wait, Gabby and Fred. Yes, what goal?
On the sum and difference identities, like alpha and beta says plus or minus, and on the sine alpha, and then like the sine and cos, like the other side of it, it also says plus or minus. If one side's plus, does the other side have to be plus too?
In a sine formula, not in the cosine. In the sine formula it does. That's why I wrote them out individually.
that's minus, that's plus.
Well, it was just a lot to remember.
Oh, I know. Yeah, and we're just starting. I don't expect you to remember it right now, but I told you, you need to start learning it. So you can't wait till the night before the quiz. right?
And
Yeah,
then
you're right.
And start learning it right now.
cosine B down.
How do you think?
Cosine A, cosine, and
Let's
then
do-
3 alpha.
One at a time.
Times pi.
Perhaps what's left equals
Pi
that.
over 3 times pi.
Same thing here. Do you not understand?
See how that's cosine, cosine?
No, I do,
sine,
it's just like new materials.
It's so good. That's gotta be kept.
It was true. Two times three is not even five.
Cool, yes it does.
Well, no, I added them together, that's right. I added them
No,
together.
like, in this equation, it was graphing, like, I thought it was,
Sign
moving
that
to my
symbol
kids'
always
back
says
there. Like over here?
You have to flip it.
Oh, yeah, wait, never mind, I don't question my head. Okay, they're both signed, never mind. Okay, so that was the little.
Raindrop.
Which one's false?
I'm gonna figure out this one.
How do you know like which one to subtract from?
Wouldn't that be 10? So it's gonna be sine, so it's automatic. Wouldn't it be 50? It's gonna be sine. So it's actually 50.
It's minus, you do plus.
Okay, which, did you come up with a false for number 2?
The second. Three.
The second one? Indeed.
No, the second
Because the second one is the cosine alpha plus beta. And when you add 2/3 and 1, you do not get, well, first of all, it's gonna be a cosine, not a sine anyhow, but angles don't work either. Number 1 and number 3 were true. This is your sine alpha minus beta. And this is your your doubling, that sine 2 beta. So those work. So B is your false one. 2, statement 2 is false.
It's minus, but I don't know how it's negative. Because cosine, you do the opposite. Stupid. I don't get a negative.
Sine, cosine, cosine, sine.
Are you sure? Do you just put the bigger number first?
When is gonna be our test over this?
Oh, alright. But that is equal to something. 8 times, yeah. Alright, you can have it.
All right, let's look at number 3. Some of you are still struggling. Let's look at number 3. I'll show you my strategy. It doesn't necessarily need to be your strategy. And I have the benefit of having them memorized. So I look at problem 3, statement 1. I'm leaving out all the numbers. I'm just looking at the pattern of the formula. It says, statement 1 says sine cosine minus cosine sine. So I know, and you have on your sheet, that sine cosine minus cosine sine is a formula for the sine of alpha minus beta. And in this problem, alpha and beta are pi and pi over 4. When I subtract those, I get 3/4 pi. I'm supposed to be getting cosine 5 pi over 4. That one's not true. That's false. Now, let's do this one. This is a formula, cosine cosine plus sine sine. That's a cosine formula, and it's alpha minus beta. So my alpha and beta are 2 pi and 3 pi over 4. When I subtract those, I get 5 pi over 4, that's true. What's cosine squared minus sine squared? That is a cosine 2 times, double. And my angle is 5 pi over 8. So that one's gonna be cosine 5 pi over 4, that one's also true. You could have ruled this one out right away because it's a sine, you don't need a cosine. All right, turn it over, see if you can do the back. Let's see if we can figure out which one's false. On the back.
Yes. Yes, it was. Kelvin, yeah.
This is for. If I like made a Quizlet with all the identities on it, could you like post it to Canvas for everyone else?
Because I know how to do that.
You could probably do it for us.
Oh, wait.
Well, I don't know how to post stuff on
You
it.
just give me all your passwords and social security number, I can help you with that.
Go ahead and make it, send it to me, I'll find somebody to help me put it up.
Huge goal. Huge for the program.
It's not that hard to say.
No, you don't. I'll be honest. You probably could just look it up.
Yeah, there's probably
There's already one.
But
made.
like typing it in would help me memorize it.
I was just gonna say, save the time.
I'll use yours then.
So 9 pi over 8, and then 9 pi over 8.
What do you want?
Number 7.
Oh, I'm starting to memorize them.
I haven't gone any further than that, so you can't do number 7.
I just don't know what. I'm sure you can, but I mean,
It'd be 9 pi over
still know anything.
Mhm.
Which formula is it?
It's cosine 2 theta equals that.
Oh, I thought that was one big
Yeah, that's right.
Oh, she wrote this one more. When you're doing cosine, actually this one's line up. When you're doing the top ones over here, you're doing the top ones. So when you're adding AB, you're subtracting these. So I return it around. Cosine A plus B equals cosine of A, cosine B
Oh,
minus
okay,
okay, I'm just
cosine
being
A.
smart. I understand what it's
So write that out.
That's okay, it's in here. Cosine.
1 minus 2 sine.
So actually, it's 5 over 8 equals 5. Okay, perfect. I just got it.
Cole, have you done 7 yet?
No, I was doing it.
I'm looking at it because you were talking about it. I don't know.
I've only gotten one.
What?
I've only gotten one true one so far. Because I'm just like trying to figure out where to start.
Yeah, this is really confusing.
It just takes.
Why are there 2 betas on it?
Just think of it as the same thing as
Like data?
the first one.
cosine 2 theta, the double.
7 looks doable, I just don't want it.
Bro, I cannot draw this on a fish sample,
Then make it an X. You always change your variables. make it an X. All right, let's look at number 6.
Logan figures it out.
Let's see, you may not be there yet, but would you just pause your thought for a second and look at number 6? What does statement 1 say? Cosine squared plus sine squared? And what do we know about that? Regardless of the angle, I don't care what the angle is, as long as it's the same, it's gotta be the same. But as long as the angle is the same, it doesn't matter what it is. What's cosine squared plus sine squared? 1, period. So statement 1 is 1. Now, statement 2. What is the Pythagorean identity that connects secant squared and tangent squared? 1 plus tangent squared is secant squared. Right? So if I put them on the same side, then wouldn't it be secant squared minus tangent squared?
This is plus on.
Okay, so that's the false one. That's the false one, because it needs to be a minus. Now, let's go ahead and look at the bottom one. 1 plus cotangent squared is cosecant squared. If I put them on the same side, it says cosecant squared minus cotangent squared. Isn't that what I've got for statement 3?
It's actually 3.
So 1 and 3 were right, but 2 was wrong. As Cole pointed out, that needs, well, it needs to be a minus, but on the paper it's a plus. All right, now, how are you faring with number 7? As always, there are a couple of ways that we can do this. One way is to think of this as cosine 2 beta squared. Now, I have some formulas for this. One formula I have for that is cosine squared minus sine squared. Look on your paper. That's one of the formulas for the cosine of 2 beta. But I need to square that. So that means I'm going to have to FOIL. So what are I going to get when I FOIL that? Cosine to the 4th.
Minus 2 cosine.
2 cosine squared sine squared plus sine to the 4th. Does that by any chance match any of my answers? So statement 3 is true, because I just got it. Statement 3 is true. Now let's back up. Remember when I changed cosine 2 beta into this? What else could I have changed it into? 2 cosine squared minus 1. But I need to square it. So what do I get when I square that? 4 cosine to the 4th minus FOIL. 4 cosine squared plus 1. Is that one of my options? Statement 2? So I have just, using my formulas, derived statement 2 and statement 3. So statement 1 must be false. Let's see why it's false. The other option, there are 3 options that you have for this formula. The other one is 1 minus 2 sine squared. What do I get when I square that? Is that on my list?
just also do cosine squared, like for the one that equals cosine squared, so could you use like the Pythagorean one?
Yep, you absolutely can.
Cosine squared equals 1 minus sine.
Yep, yep, yep. These things are kind of like proofs in geometry. There are lots of ways to get from A to B. We all kind of have our own thing. And sometimes it's fast, sometimes it's a little more long, but eventually we'll all get there.
I hate proofs.
There's a lot. Okay, let's take a quick look at the homework for this section.
Proofs are terrible.
Not assigning it yet, I'm just asking you to take a look at it. 312.
Grade 11 due tomorrow.
It was due tomorrow.
It was due tomorrow.
Jeremy.
I see that on YouTube like at least twice a day.
Several of these we have already talked about, but I want to look at number 4, because we have not yet looked at number 4, a problem like number 4. So this is on the 312 homework, problem number 4. Find the cosine of 11 pi over 12. Now, I want you to think about your special angles. Your special angles are pi over 6, pi over 2, pi over 4, and pi over 3. And then all of the corresponding ones. So 2 pi over 3, 3 pi over 4, 5 pi over 6, and so on around the circle, right? Those are your special ones. I want you to come up with 2 of them, any 2, from anywhere on the circle, that either add or subtract to give you 11/12. Okay? So if we're using those, I'll need one with a denominator of 3 and a denominator of 4. That would give me 12. Okay. So what are 2 of those that will either add or subtract? I put a plus, it could be a minus.
2 pi over 3 and pi over 4.
2 pi over 3 and pi over 4. Let's check his math. This would be 8/12, and this would be 3/12. Does that add up to 11?
I think so.
Yep. Now, this is where Alex's point comes in. Are there other combinations we could be doing? Yes, there are many. We'll go with this because it was the first suggestion, but there are many other ways that you could start the problem. So what's step 1? This angle is not on your unit circle. It is not special. So what you must do is find 2 other angles that are special that either add or subtract to this one. We're choosing to add these 2 together. Now, this is my alpha, this is my beta. What does my formula for the cosine of alpha plus beta say? Cosine alpha,
Cosine beta.
cosine beta,
Minus
minus,
sine alpha sine beta.
yes.
I remember that.
Now, this is day 1 of the formulas. No one expects you to be an expert, but on your sheet, you have a formula for the cosine of alpha plus beta. And it literally says, written in black and white, cosine, cosine minus sine, sine. So now guess what you get to do? Now you get to figure out what are these 4 values. What is the cosine of 2 pi over 3? What is the cosine of 2 pi over 3? Be careful.
Negative.
-1/2. My might as well do this one. What's the sine of 2 pi over 3? Root 3 over 2. What's the cosine of pi over 4? Root 2 over 2. And so is the sine. Right? So now these two get multiplied. So that will be negative root 2 over 4, multiplying, minus these two get multiplied, root 6 over 4. Since they already have a common denominator, we'll go ahead and put them together. They don't really simplify though, because you can't combine, you can't subtract a negative root 2 minus root 6. You just kind of have to leave them like that. Okay? So one more. Let's try number 5. The sine of 7 pi over 12. So now you're doing the same thing. We're doing the sine of 7 pi over 12. Don't say anything. Everybody see if you can figure out, using your unit circle angles, a way of expressing 7 pi over 12. You're either adding or subtracting. Come up with something? What? Pi over 4 plus pi over 3. Does that make 7/12? I'm gonna add it. It's a great option. Not the only option, it's a great option. All right, what does our formula say for the sine of an angle plus an angle? Alpha plus beta.
Sine of alpha.
Sine of alpha.
Cosine of beta.
Cosine of beta.
Cosine alpha.
Wait, I need a sine.
Plus
Plus
cosine beta. Sine.
cosine alpha. Sine beta. Yep. That's exactly right. And then what do? You're not done. Now what do you have to do? Evaluate all those, which should be easy for you because they're straight off your unit circle. So that's gonna be, what are the pi over 4s? They're the easy ones. Root 2 over 2. Pi over 3. What's your cosine? 1/2. And your sine is root 3 over 2. Everything's positive because these are both in quadrant 1. So this time I'm going to get root 2 plus root 6 over 4. Is that what you got when you did it?
Yeah.
Now, we've only done 2, but I'm going to just tell you, you're going to get answers that look like that a lot. Can you explain to me why my answers are always going to look something like this? Because I'm always using what numbers? Root 2 over 2, root 3 over 2, and 1/2. Aren't those your unit circle numbers? So no matter whether you're adding or subtracting or what you're doing, those are going to be your numbers. All right, we will continue this discussion. I'm not assigning that homework yet. I'm going to go ahead and work on it if you have a chance.